Hey, boys and girls. Sorry I can't be there today, but at least you get to hear my voice, right? So at least everyone's happy. Anyway, please take out your notebooks. We're just going to run through a couple of things for Chapter 2.2. All right. First of all, first thing you want to know is that this unit, we're going to be talking about if-then statements. And an if-then statement is exactly what it sounds like. It's a statement that uses an if and a then. So one thing would be if Mr. Katz is absent, this would be the hypothesis. Then students will cry. And one of the things we do in this chapter is we give statements variables to kind of just sum it up. So this would be the P part of the statement, the hypothesis, if Mr. Katz was absent. Then the following is going to happen. Students going to cry. We call that the Q part. And again, these are just variables that just so we can write a statement like this, showing that P implies Q. And that's one thing that you're going to want to make sure you remember. And remember, this is going to be online in case you can't get all the notes down. So P implies Q means that if P happens, it's going to automatically imply Q happens. So in this case, Mr. Katz being absent, if I have this statement, if I write this, I know that the students will automatically cry. And I hope, and remember, there are tissues in the back of the room in case anyone's too upset that I'm not here. All right. So then you have a converse of a statement. Now the converse is pretty much if you take the original P and Q and you just switch them around. So instead of saying P implies Q, we're going to say Q implies P. So then we could write the statement. The converse of that statement would be, if the students cried, then I know Mr. Katz was absent. And that would be the converse of the original statement. Oh, you know what I did forget to say is that the original statement we also call the conditional. So the original statement, if Mr. Katz is absent, students cry, that's the conditional. That's the P implies Q. And notice I use the arrow going from P to Q to show that it's the P that implies the Q. And the converse, again, would be if the students cried, then Mr. Katz was absent. All right. Next thing in the chapter you should be learning about is called the Euler diagram. Euler diagram. And what an Euler diagram is a way to show deductive reasoning or deduction. And let me kind of show you that in a second. But again, deductive reasoning is reasoning based on logic. Now, if a triangle is equilateral, then it is isosceles. Okay, so here's a conditional. Now, an Euler diagram is a way that we can show that in a diagram. And we have, some of you did this in IM, you have the universe. So what's the universe and what's the element in that universe? Okay, so we want to show that if it's isosceles, if something is equilateral, it's automatically isosceles. So that would kind of tell you that anything that's equilateral will automatically belong in this heading. So our big heading is going to be isosceles. Okay. And in it, we have a specific type of isosceles triangle, which is a little more specific, which is equilateral. Sorry for the handwriting. So this shows you that if I have a triangle that has 3 equal sides, it would go right in this circle. And if it's in this circle, you can see it's also part of this box. So this kind of shows you that all equilateral triangles are also isosceles. And remember, the reason is that to be an isosceles triangle, all you need is at least 2 sides. If you know you have an equilateral triangle, all the sides are equal. Therefore, you automatically definitely have 2 sides that are equal. And this right here is an example of an Euler diagram. And there's a couple more in your book in chapter 2.2 that you could kind of see. All right, so one thing I want you to do is you're going to read page 93 together. And this is after I'm done with this slide, this is an example of a logical chain. And a logical chain is nothing new. It's just a series of if-then statements. Those of you that have ever read If You Give a Mouse a Cookie, it's just that whole book is one big logical chain. I'm not sure if you guys are familiar with that. And the big thing about logical chains is you can group the first thing, which we call the hypothesis, with the last thing, which would be the conclusion. And that shows one causes the other. And before you guys read page 93, to see that example of a logical chain about the mice, I can give you a smaller version of a logical chain which is right here. Okay. If Mr. Katz is absent, then the students cry. If the students cry, then they can't eat lunch. So this would just be two logical chains grouped together. You notice how one ends off students cry and the next one picks up students cry. And the one thing that you can use is you can use the transitive property when you make a logical chain. And what the transitive property is, it's generally if A implies B and B is going to imply C, then we could automatically say that A will imply C. And if you look at this example, we can start off, if Mr. Katz is absent, then students cry. If students cry, they can't eat lunch. So I can take the first thing, and I know, using the transitive property, if Mr. Katz is absent, that's going to cause the school not to eat lunch. And again, this is just taking the transitive property and going through. All right. And again, I know I want you to read that logical chain, but tomorrow, please, which is Friday, please bring your compasses tomorrow and colored pencils or pens as well as a straight edge. You don't necessarily need a protractor, but you do need a ruler. Make sure you guys have that stuff in class. For tomorrow, you're going to be doing an assignment. For now, Mrs. Stein's going to let you know exactly what you could do in class to kind of read back up over this chapter. And this is going to be available online to you at home if you didn't get the notes and I went too fast. Hope you have a good day.